Today we're doing section 3.2, day 1, and we're going to be talking about logarithmic functions. So the first thing that we're going to discuss, which is so important, is the difference between log form and exponential form. And again, you did do this a little bit in Algebra 2, so this should be somewhat of a review. So log form, very obvious, we'll have the word log in it. So I have log base a of b, and it's equal to x. So this is log form. If we're going to convert it into its equivalent exponential form, the base is a, it's raised to x, and it's equal to b. So notice exponential form obviously has an exponent and there's no log, and they kind of get jumbled around. One thing that they do have in common is that the base in log form is the base in exponential form. So we're just going to practice going back and forth between the two forms. So here you're in log form, they want you to put in exponential form. So my base is b, it's raised to the second power, and it's equal to x. For letter b, my base is 64. It's raised to the third power, and it's equal to x. For letter c, I have log base 3 of 7 equals y. My base is 3, it's raised to y, and it's equal to 7. So notice it doesn't matter which side of the equal sign log is on, the property will always work. Now we're going to go the other way. Now you're in log or exponential form, and they want you to write it in log form. So I have log base 12 of x equals 2. Letter b, I have b to the third power equals 8. So it's log base b of 8 equals 3. And lastly, letter c is a little different because I have a base of e. And whenever you have a base of e, you now switch over and you use natural log. So I have ln, the base is e, of 9 equals y. Now, I just wrote it out for the sake of you understanding where everything goes. You won't normally see the e. The base of natural log is implied to be e, so normally you would just see it written like that. Would I take points off if you wrote the e in there? Absolutely not. So just a little quick recall on exponential functions. So if I have the square root, okay, so the b root of x to the a power, the way I could rewrite this with an exponent would be a divided by b. Okay, so a square root or any kind of root will always have a fractional exponent. Another property, if I have 1 over x to the a, that means that this is x to the negative a power. That also works like this. If you have 1 over x to the negative a, you could bring it up and it'll now become x to the positive a. So the negative always moves its place in the fraction, whether that be top or bottom. So now we're going to go into actually evaluating these. So the goal is to figure out what the exponent would be. Okay, so remember when you're writing these in log form, it's always equal to the exponent. So if I put this in exponential form, I have 2 to the x power equals 16. So some of these you might be able to do in your head. You might say, oh, I know 2 to the 4th power is 16. If you don't know that, we get the same base on both sides. So 2 to the 4th is 16. Therefore, x equals 4. So some will be easy to do, not some, not so much. Letter b, we'll set it equal to x first. So I have 7 raised to the x equals 1 over 49. So my first matter of business would be to change this to be 1 over 7 squared, so I can clearly see I have the same bases. And now if I want to bring this up, this will become 7 to the negative second power. Therefore, x equals negative 2. Letter c, I have 25 raised to the x equals 5. Left side is going to be rewritten this time, so 5 to the 2, which is still raised to the x. When I have a power raised to a power, I multiply my exponents, so I can say this is 5 to the 2x. Over here, this is 5 to the first power. Therefore, 2x equals 1, so x equals 1/2. And if you think about this, again, the exponent of a 1/2 means the square root. So 25 to the 1/2 power is the same thing as saying the square root of 25, which is 5. And that's kind of how you can do a little bit of a check. All right, and lastly, letter D. I have 2 raised to the x equals the 5th root of 2 to the 1st power. So I need to rewrite this right-hand side. I can say this is 2 to the 1/5 power. Therefore, x equals 1/5. All right, that's all for today.